it's very common, and it's not just and it's not. Now they were doing in a month or maybe once in 2 months. The moment it shrunk so much, they're now thinking about more releases, and that's what businesses finally want. The moment I have an idea, can I take it to production very quickly, right? That significantly changes, and this automation actually allows you to do that. So that's pretty much all I have. There is a little booth behind, and my colleague Lenin is sitting there. We have some brochures. If you have questions, feel free to ask him. Do drop in your cards. But before we end, if there are maybe we have time for a couple of questions.
We will take 2 questions.
2 questions. Yeah.
One more.
With this stuff and virtualization, because and another thing is, what is the best tool right now available in the market if can use for virtualization? In my company we are using IDQ, so I'm not.
Which one is using?
IDQ Lisa.
Okay, so CA has acquired that almost 4 years back. So that's what we're talking about actually. ITQ Lisa.
Right. Because once you create stuff and virtualize it, right? If the application functionality changes in every release, so what is the maintenance involved? I mean, we have to go back and change and re-record those transactions again, right?
So I don't know do you know which version you use?
No, I'm not sure.
Okay, so that's fine. So I think there is very little maintenance required, right? Now, if I build a new service, of course I have to re-record it. But if the existing service changes, right, we have an ability to actually understand those changes and build it into our virtual service. So it's almost like a self-learning. We actually call it a self-learning mode of that recording, which means that I record the same service, but because it has changed, I will understand what parameters has changed and things like that, and I will almost self-learn it, almost without having to intervene. There is some, obviously, there is some limit to that, but the point is that, a service is not going to drastically change 180 degrees, then it would be a new service. But if there is a sort of incremental increase in that service that we have virtualized, then that incremental change we can capture automatically in a sort of self-learning mode and, keep that maintained. Does that help?
And which other tool would you recommend as a virtualization other than this Lisa?
CA Lisa is one, and the second one is CA Lisa. That's it. The problem is, I think, I'll tell you, the next best competitor that we have has probably 10% of our customers. And, because IT, so this is an acquired company, and they were the pioneers of service virtualization in 2005-06 time frame, right? And so we are much ahead. We, as in, that acquired company has been moving along much ahead. We are 2 or 3 generations of capabilities ahead. And you ask around, and I know, I'll tell you, IBM is the next best competitor, but you ask them how many customers you have. We have 250 customers worldwide. You name the top banks, you must have seen there, top banks, top telcos, all of them are there because we have the capability, right? And there is a reason why you are chosen that versus something else also, right? But if there is some issue that you're talking about, we can take it offline if there is, discuss that.
How is this different from the concept of drivers or stuffs we use in our test environment? And I also wanted to know the general risk factors associated with this approach.
What factors?
Risk factors, the general risk factors.
Right? It is hard to maintain. It's a piece of code that a developer has to work with. And it's not intelligent enough. Stuff by itself is not intelligent. You have to build that intelligence into it. Whereas service virtualization actually captures all that information that is just recording or from the request response pairs, and it has built-in intelligence. For example, if I have to respond with a certain parameter, like I'm simulating an ATM transaction, for example, right? I'm withdrawing X amount of money. I'm withdrawing, or my balance has to decrease by let's say $40 or 1,000 rupees. I record that. Now, it has the intelligence to know that if I have a different customer, if I have a different transaction, if I have a different amount, it will still continue to work with that, with that operations. If there is a slight variation in that operation, there is concept of a magic string, which means that you're able to give it that intelligence that if string value changes, then it automatically responds with some sort of a logic that we have built in there, so that, you know, we don't have to build in a lot of logic around those services that we have virtualized. With a stub, typically what happens is you're sort of doing it for a specific type of a request and a response that you have, and then that it has to be maintained. It is not scalable. Tomorrow, if I have to virtualize, you know, hundreds of services, you can record a service in this probably in 2 hours. A web service, in fact, yesterday we did it for a customer. We were doing a demo. We took their banking, you know, I think the customer experience management and a back-end mainframe. We did it probably in 45 minutes. They had a request response. Actually, they gave us a WSDL, okay? And we took that WSDL, created a dummy request response pair, made some changes to the data, and created a virtual service that now that customer experience management system can point directly to the virtual service, and they are already ready to test within 45 minutes. Okay. So the speed with which, yeah, and Lenin can probably add to that as well.
One thing, now we have different development platforms, like C, C++, or even Java, or .NET. Whatever the service virtualization we are trying to build over here, will that accommodate all the technologies, or is it relevant to only few?
No, so we support a lot of technology, but see, what matters to us, because we are basically, there is a system under test, and there is a constraint or a dependent system, and there is traffic flowing between them. What is the transport protocol and what is the data protocol between them? As long as we are able to virtualize that transport and data protocol, we are okay. Your program could be in C, your program could be in Java, you could, you know, any other, doesn't matter, right? Transport protocols are standard. You know, you have HTTP, HTTPS, you know, SOAP web services, JMS, MQ, whatever, right? So all of that we do. You know, we in fact virtualize 85 protocol, 8583 protocol, which talks to the, you know, backend switch for an ATM, right? So, you know, obviously banks need that, because, you know, that switch is not always available for testing. They are making some changes. So we do a lot. So we have pretty broad variety of protocols that we support, and that's what basically matters. What are the two systems communicating in? Because now we want to get rid of this and virtualize it. So we understand that communication and replicate that in the virtual environment so that it works.
Transaction level interaction, what we are talking about. But when we see the entire release automation, the release has multiple things. Like
Correct.
build process, build as
Correct.
technologies,
Yeah. Correct.
and again you are triggering.
Correct.
These are entire life cycle of the release.
Correct.
So release support all different variants.
We support very broad variety of, yeah, you know, you talk about WebLogic releases, Oracle releases, WebSphere, you know, Tomcat, Oracle application server, or whatever. So we support all of these. You know, again, you know, I don't want to take too much time, but we have, you know, Lenin can give you more information if you have specific things that you're in mind. But we support probably 95% of the technologies out there when it comes to releases as well. And you know, you can always go to ca.com/DevOps and you will learn more. You can talk about it.
What I see over here is that, you know, a couple of them still continue having questions. So what we can do as a result is the ones that have questions can perhaps move to the side while we break, you know, for a quick tea coffee break. The rest of them can start having tea, and the ones that have questions also can actually, you know, bring your tea coffee and you can continue with your questions. So, you know, likewise, we can also cover up on the time and we can be on schedule. Yep.
Considering the different domains, since I'm coming from the engineering company background, so we have some sort of hardware. So will that be a good choice for that sort of environment?
If I understand correctly, your question is, when it comes to different domains, this solution can be, if it will fit across all domains. So, see.
And just to add it is like, can we completely rely on this service? So it's like as a part of testing, can we completely rely on this service virtualization? and just don't go with the hardware, just go with this one and test everything and just go let the bill go to the market directly.
So let us look at like this. So if you look at any enterprise application, there are disparate systems talking to each other. Let us take an enterprise release. Assume that take a telephone. No, I don't have a system that will talk to each other. A simple use case like I want a new connection, right? As a user, you go and I want a new connection. But what happens at the back end is a big work that will be done, right? The lead needs to be generated, converted into order, convert your call and take your right? Convert that into an order. Then order goes to convert billing record, customer number management, right? If you look at particular releases,
that's fine.
It's a common observation that out of 50 systems, only one or two systems are undergoing change. All the systems are like the same way, working the same way. Take for example, if you are doing a retail system, you just
we'll practice with it.
All you do is send some information from your side, get back the response, validate. That system is not changing. And what are the, if you want that system to be available to the enterprise landscape, there are a lot of overheads, right? Cost managers, they will be doing, who will be managing that application, right? If there are outages in that application, your end-to-end journey cannot be tested. So this is one part. Second part is that in these kind of scenarios, it's better to virtualize that behavior, like not the system behavior, right? Now, once you virtualize, how do you virtualize? By simple concept.
We are a pair. So two mics would be arranged, right?
One hand mic, this mic is one
Caller mic.
one two caller mic.
I think one caller mic would suffice. I will use this mic. And that's okay.
So now, if somebody says on production behavior or something,
Yeah, that's okay.
that's a different matter. But you are assured and guaranteed that the same behavior is coming into play with people. That is one, right? And there is the concept of modeling. You can always ask your virtual service to hold regularly and see whether something has changed at the real system. If there is a change, it will alert. So these are certain mechanisms that are available out of the box for you to make sure that the quality of service.
I think that's okay. We will not. That's okay.
Hardware is like the transmitters, so that is our product. So our different, the cooling technology appliances. So if you want to test that one or replicate or simulate those sort of hardwares, then it's like how that's possible, how that can be virtualized.
तो मिल जाएंगे अगर मांगेंगे तो.
We will be starting off with Mr. Praveen Yadav and Ms. Sonia Vora, who are associated with Ericsson Global. So a brief introduction about yourselves and you can continue with the topic.
All right. Let's start with the introduction, who we are. Myself, Praveen Yadav. I'm working in Ericsson for the last 3 to 4 years, and my total experience is around 8 years. And my roles and responsibilities includes the verification of the end-to-end systems which we deliver. And my counterpart is Sonia Vora. We both work in a team cohesively for the delivery of the product which we test. So this is a brief introduction about us.
Hi to everybody. This is Sonia, and I'm working with Ericsson Global presently, and I'm working for the past 3.5 years. And rest has already been talked about, Praveen. So let's continue.
Okay, the lineup items would be something about big data. What is big data? My friend Mr. Anand has given you a very wonderful presentation to you in the morning, the first session, and I hope you have all the most of the queries related to big data. You can park to us as well, and we will have an overview. What is the problem which has been already been described by Mr. Anand. Then we will cover the 3 V's of the big data. Then what is big data testing? What are the challenges and technologies and tools used for big data testing? Then we have one slide for Ericsson ways of working, since we are working into Ericsson, and Ericsson is a telecom-based company, and so we'll cover one slide onto that. Then we have ROI from big data testing, like every organization who is going to invest a lot of money on doing huge investments, then they will surely expect something as in the return, that the return of investment. So let's start with this. Now, I hope you all have a brief knowledge about big data. So, and can any one of you can tell us define what is big data? Any of you? Okay. Well, big data is something which is there everywhere. It is there in the devices, your mobile devices, your laptops, the network elements, the social websites. So that all the data being generated by various types of instruments, scientific instruments. So all those data contribute or can be termed as big data. So in one line, we can say big data is a data set that are too large and complex to manipulate with or interrogate with standard methods or tools. So it is not that we have to have some tools or some standard methods to check whether the big data or the data which